Okay, so we actually have the same matrix. A and B are still the same, but this time what we're doing is we're finding B cross A, right? B times A. So again, we want to find the dimensions of the matrix, the two matrices. We already know that this guy is 2 by 3, and this guy is 3 by 2. But this time what we're doing is we're multiplying B to A, right? So B to A is actually, B is a 3 by 2, and A is a 2 by 3. So the question is, do their inner numbers match? Well, they're both 2, right? So guess what? Yes, they do match. So that means we can multiply these two matrices. The second question is, what are the dimensions of our resulting matrix? Well, the inner numbers tell us if we can multiply them, and the outer numbers tell us what the resulting matrix size is. So 3 by 3 will be the resulting matrix when we multiply this. See? We have another square matrix. This one is size 3 by 3 though. So it's important to remember what each group of numbers represent. The inner ones tell you if you can multiply them. The outer ones tell you the dimensions of the resulting matrix. Okay, and again, we're going to go ahead and do the same thing where we're going to compute the dot product for each thing. Remember, we're going to multiply each row of the first matrix by each column of the second matrix, right? So we have to flip things around a little bit here. So we're going to get a bunch of entries. This first guy, he represents us multiplying or finding the dot product of the first row and the first column. And now we should have a better idea on how to calculate the dot product, right? We multiply the two first items, and then we multiply the two second items, and then we add them all together. And we're going to keep doing this for every single row and every single column. So we're going to get a bunch of combinations. We should get like 9 of them, right? There's a bunch of them. So we're going to do this for all of them, right? We go through row 1, column 1, row 1, column 2, row 1, column 3. Then we switch the rows. Row 2, column 1, row 2, column 2, row 2, column 3, and so on and so forth. So we're going to get a bunch of numbers. We're going to get 9 different numbers, and our goal is now to just plug them into the resulting square 3 by 3 matrix. Remember, this is a super useful notation because it helps us on so many levels. It tells us which rows we're crossing. So I'm finding the dot product of the second row and the second column, but it also tells me where I should be putting this in my resulting matrix. This entry should be in row 2, column 2. So following the same method as before, we come down here, we fill out our resulting matrix with all the previous inputs that we just found. So one thing I want you guys to realize is this. We crossed A, we did A times B in the first example, and this was our resulting matrix. And then we did B times A, and we got this. So what does this tell us? This tells us that A times B does not equal B times A. Matrix multiplication is not commutative. It's not like regular multiplication, right? If I'm doing regular multiplication, 2 times 3 is the same as 3 times 2. But for matrices, when you multiply matrices, it is not the same. We saw that one resulted in a 2 by 2 matrix and the other one resulted in a 3 by 3 matrix. Completely different. Yes, they're both square matrices, but they're completely different matrices. So just be wary of that. Matrix multiplication is not commutative. And there's a bunch of rules for matrix algebra. I think I posted it. Yeah. So there's a bunch of rules for matrix algebra. So you'll see that A plus B equals B plus A, meaning that matrix addition is commutative, right? However, what we said right here, matrix multiplication is not. But that's the only one you really have to worry about. Everything else is the same, meaning addition is commutative, the associative law still applies, the multiplication associative still applies. You can even distribute matrices. And of course, you can multiply by constants and stuff like that. But so everything is similar to regular algebra, but the only thing that's different is this guy right down here. He's the biggest one. That matrix multiplication is not commutative. And we just did an example that proved that. And guess what? Most likely they're going to have that on your test. Your instructor will test you on that knowledge. So just be ready for that. Okay, guys, good job.